Okay. Clap your hands and jump up and down if you see it. The recording stops, so I know for sure this time. All right, one more time, everyone. What do you know about the Bay of Fundy? It is in Nova Scotia. Very good. And it is renowned for what? In the whole world. Every 6 hours and 14 minutes, the tide differential is what? 55.8 feet from high to low. Exclamation point. Wow. I'm at a loss for words. Let's record that. All right. If we assume, we're already in dangerous territory, right? Because you know what they say, if you assume. That on a particular day, we're observing a low tide at 8:45 a.m. We're there at 8:45. It's low tide. Like, hey, look, the tide is low at its lowest. It's 8:45. I wear my watch on the other hand. There we go. Part A, sketch the graph of the tides in feet for the entire 24-hour day in minutes after midnight. Assume the sinusoidal axis is at y equals 0. So we're going to let y equals 0, the x-axis, represent sea level, okay? And we're going to measure how high above and below normal sea level, which is a good benchmark for any kind of elevation, how far it is above and below sea level. So here we have to do a little bit of work. We are measuring the x-axis in what units? Minutes after midnight. Woo-wee. Okay. So here's what we have to do. We have to kind of figure this out. So come down here and let's do a little bit of planning. I know that 8:45, it's at a what? I'll call it a.m. It's at a low point. I know that every 6 hours and 14 minutes, 6 hours and 14 minutes, it's going to change between high and low. Now, you can convert everything to minutes if you'd like, but let's kind of keep it with hours and seconds for a second, for just a few minutes, seconds, for a while. There we go. 6 hours and 14 minutes, then, between a high and a low. Is that the period? Is that the length of a full cycle from one high to one low? Is that a full? That's a half cycle, right? So the period is going to be 12 hours and 28 minutes. Okay? So let's work backwards from 8:45. And you tell me, do you want to work in hours and minutes, or you just want to convert it all to minutes right away? Convert all to minutes? Okay. So 8:45 a.m. is how many minutes after midnight? Well, 8 hours is how many minutes? Yeah, 8 times 6 is 480. We got 480 minutes plus another 45. You could do some old school addition right there, right? So it's 525 minutes after midnight. That's 8:45 a.m. All right, we want to work backwards by quarter cycles. So let's go ahead and convert a period to minutes. 12 hours is how many minutes? 720. And then plus 28, you get 748 minutes. There's the period. Good. Good. So I'll just slide that over here. Now remember, what we're after is the axis, low axis, high axis, low axis point. So once you figure out the period, we count by what fraction of a cycle every time to a new critical value? A fourth of it. So right away, you can go straight to your critical value number, which is a fourth of the period. And 748 divided by 4, does it go in evenly?
Yes, 187.
180 did faster than I did. 187. So every 187 minutes, we are going to have a new critical value. Now, you're going to have your calculator on the test tomorrow, so you can use it to help you, right? 748 divided by 4. So let's go ahead and work backwards. On your calculator, go ahead and type in 525. 525. Ooh, not that one. You'll need a calculator. You can borrow mine today and tomorrow. And let's go ahead and subtract 187. We get 338. Now, if you subtract 187 again, remember, if you do something twice in a row on your calculator, it remembers what you did. So you can just keep hitting enter. Now, what we want to do is we want to keep subtracting 187 until we get to our first negative value. Remember, I always say you want to graph at least one value to the left of the y-axis. The y-axis represents what time in this problem? Midnight. Good. So I'm just kind of organizing my information here. As I work backwards from 525, I get 338. And then the next number was 151. And then I got negative 36. So what I'm writing on my paper / iPad is this. I have 525. I know it's at a low point. So I'm working back a critical value at a time by subtracting 187. Boom. I hit my negative number. Now you can oscillate your values. If you work backwards, it doesn't matter if you're low going forward or low going backwards. There's only one place to go when you're low, and that's what? Up. So if you work backwards from low, you have an axis, and then a high, and then an axis point. So notice this is important because this is the first problem we've seen, really, where the y-axis was not our starting point. At the Ferris wheel, the guy started on the bottom. So at t = 0, it was at a low point. On the spring, he compressed it to a high point at t = 0, so it was a positive cosine. This one, you have to use the information given. I'm going to tell you where it's at a high point, where it's at a low point, and you just work backwards like that, and now you have your critical values. So once you have that, you can go ahead and make the rest of your graph. We're ready for the final graph here. So I'm going to go ahead and do this. We're going to graph it above and below y = 0. We're going to let the sinusoidal axis be 0. So here's what I'm going to do. I know my first critical value to the left. I'll use blue for water. It's going to be negative 36. Now 151 is going to be somewhere right over here. See that? So I have my two critical values down. Once you have your spacing, 36 is pretty close to the y-axis, 151, not quite 5 times away, 4 times away, but it's a little farther away. Now you have your spacing between your critical values, and that's what you eyeball, and that's what you kind of preserve as you put new critical values down. And if you need to extend your axis, go for it. All right, so the spacing is the same now all the way through. Now, if you want to create critical values, go to your calculator. We're at 151. Let's just keep adding back a quarter cycle now, plus 187. And, of course, we know that's 338, so you can label it on your graph. If you do it one more time, plus 187, of course, you get 525. And now you can just keep hitting enter, and you can label 712, hit enter, 899, hit enter, 1086, hit enter, 1273, hit enter. How long are we going to go here? That's 1460. Yeah, you need to know how many, we want to do it for a full day, right? So how many minutes in a full day? 24 times 60. So 1440. Yeah, so I just went to 1460. That should be enough. So here's what I was doing on my iPad. Every time I typed in plus 187, I got my next critical value. I just labeled my axes. That's the most fun part of these problems, figuring out the x-axis. Okay, so now let's go ahead and label it. Some of y'all need to improve upon your graphs from what you're doing. Let's go ahead and label this t in minutes. And what are we going to be labeling on the y-axis? Yeah, let's call it h for wave height or tide height, and we got it measured in feet. So you're labeling your axes because they have meaning now. Okay, so we don't really think about, in this case, where did our y-axis go from the original equation, because we're not graphing this from an equation, we're graphing it from a scenario. So you don't have to think about where's the new y-axis, where's the new x-axis. You just have to realize the point that I gave you is set the whole thing in motion. We said that it was at a low tide, right, at 8:45, which is at 525 minutes. So let's go ahead and set up our y-axis now, if the difference between the high and low is 55.8 feet, is 55.8 then your amplitude? Yeah, the amplitude is going to be half of that, right? Because 55.8 is the total difference between high and low. So 55.8 divided by 2, you'll have your calculators for that awesome calculation. It's 27.9. So this is going to go up 27.9, and I'm just going to come up an arbitrary height. You'll see right here, 27.9. And then I'll preserve that distance and mark it as negative 27.9. And we've already got the y-axis measured in feet. So now we put our first point down. At 525, it was at a low point right there. And now we can establish every other critical value. So let's go ahead and do that. The sinusoidal axis, remember, is the what? The x-axis, right? So as we go to the left, we have an axis. And then at 151, we have a high. And then at 36, we're back on an axis. And then back, it's going to the right. 712 is axis. 899 is high. 1086 is back to the axis. 1273 is low. 1460 is back on an axis. So now you just connect your dots with your quarter cycle intervals. Some of y'all are kind of making V's when you draw them. Make sure that they're curvy. You want to exaggerate the bow in the graph. They're either concave down like a frown or concave up like a cup, like a smile. Okay, now, of course, the tides do keep going. So if you wanted to kind of put an arrow here to show that we're only looking for a day, but the tides continue while we're sleeping and walking away. There you go. That would be worth a check or two on the test tomorrow. That's processing a lot of information, but it wasn't really that bad. Okay, I think it paid dividends to convert everything to minutes first, so that you're working with one unit and the final units that you wanted. Okay, so now that you have the graph, you can write the equation. Write an equation that models the motion of the tides. Well, we already named our function h of t. What's the amplitude?
55.
Well, the amplitude would be the half of that, right? 27.9. You want to call it a sine or a cosine? I don't care. Cosine, all right. Positive or negative? All right, if you do a positive cosine, then the amplitude is just positive 27. We need to come up with a b value, right? We don't get the b value directly from the graph. How do we get the b value? From the period. Good. So the period is 748 minutes, so b should be 2 pi divided by 748, which when you simplify, what's half of 748? 374. Yep. So there is your nice cleaned up b value, so we could put that right here. Pi over 374. Are we going to be able to write this equation without a phase shift? No, we're not. So for a positive cosine, it's real easy. We're looking for a what? High axis or low? A high. Which high point do you want to get to? 151 looks good to me. You can even get over to 899. 151 is the closest. So parentheses. Do we put x or t here? T, right? It's a subtle thing, but it's meaningful. And I know it's going to be 151 because that's the high point. And then what's our d value? 0, right? We're on the x-axis. That's great. Now, I left it blank in between the t and the 151 because I'm not sure if it's supposed to be plus or minus. Minus. Good. Because the unshifted cosine would have a high point at t equals 0, and you need to scooch it to the right. So it would be t minus. All right, so how do we know if that equation is correct? Put it into the calculator and graph it in the same window that you just set up on your paper. And if they look the same, you got a really good indicator that you're going to answer the rest of the questions correctly. If not, tomorrow on the test, don't panic. Just troubleshoot. Raise your hand, call me over, and we'll see if we can figure it out. Because it's important to have the right equation if you're trying to answer questions. So here we go. I'm going to check the first thing first, which means mode. I need to be in what mode? Radian or degree? Radian. Okay, I am in radian mode. Now I'm going to go to y equals and type it in, 27.9. And there are infinitely many different equations for this function. I'll just require you to come up with one. If you want to use the horizontal division bar, remember that second y equals n over d. You got pi. Use the pi button. Don't type in like 3.14. 374, parentheses, x on the calculator. Oops, forgot the parentheses. Minus 151. Close it for the shift. Close it for the angle. Now, don't just hit graph or zoom 6. Go to your window and type in the window that we just did. Our x min, it went from negative 27.9. So maybe I'm going to go from about negative 30. We went all the way to, that's x. Oh, sorry. Yeah, we need to go like negative 40. I was looking at the wrong number there. We went to negative 36. So let me go to negative 40, just a little bit past. And then we went all the way up to 1460. So I'm going to go about to 1500. Now, it's not critical that you put your x scale at anything. You can just leave it at 0. That's what I prefer. And your y min, we do want to go a little bit above and below negative 30 so we can get some room to write. So maybe negative 50 to 50 leaves a little space above and below. And again, I leave my y scale at 0. You don't need tick marks or anything. And then everything else you can just leave default. Now, if you hit graph, you should see something that resembles your function. We have 2 full peaks showing and 2 full valleys showing. All right. And the pink line there is just sea level. Okay, how does that look? Perfect. Yeah. Can I get a bark? I don't know. I don't know what the noise was. I thought it was an affirmation of the awesome work we're doing here. Okay, so what does that mean? That means we are now ready to answer some questions. All right. I don't know what that was. Oh, it works. Okay. It works. Work. Got it. You got to forgive me. I've got this thing in my ear. I can barely hear. All right. Part C, at midnight the morning of. At midnight the morning of. We were there at 8:45, so back up 8 hours and 45 minutes. To midnight the morning of. What was the water level in the Bay of Fundy? And at this time, was the tide coming in or was the tide going out? All right, so how are we going to answer that question? And more importantly, perhaps, how are we going to show notationally what we're finding? Ah, very good. We are looking for the y-intercept. And you communicate to anybody that you're finding the y-intercept. I'm going to shrink that down, space bag it, put it under the bed. There we go. C, you communicate that you're finding the y-intercept on the function h by putting h of 0. If you don't have h of 0 or the equivalent tomorrow on the test, you are not going to get full credit. All right, so once you have the graph, you could just hit trace, and notice I'm on the cosine function. Just type in a 0 and hit enter. That's fine. How many decimals do we report? 3. So 308 or 309, either one will work. And then, of course, you put units on all your final numeric answers, which is feet. Are we done with part C? No. All right, let's keep reading. At this time, was the tide coming in or going out? Coming in, how do you know? Well, yeah, let's see. We're measuring the height above sea level, so the height is increasing, which means the water level is increasing, which means the tide should be coming in. Yes. So we'll say at this time, comma, the tide is coming in because the water level is rising. And you could do that just from a visual confirmation. So what tide would that be, ebb or neap? Neap tide, right, neap tide. Now we're done with part C. Is there anything else? Nope, that was it. Part D, at 7:30 that evening, what was the water level in the Bay of Fundy? At this time, was the tide coming in or going out? All right, so part D, at 7:30, that's a time value, right? So do we put H of 7:30? Ah, that doesn't work. We're measuring minutes after midnight. So off to the side here, we do a little bench work. Yeah, 7:30 p.m. that evening. So 7:30 is going to be, first of all, how many hours past midnight? If you're at military time, it's 19, right? In military time, it's 19:30 hours. So 19 hours times 60 plus 30 minutes. You go to the calculator. You got it? 19 times 60, 19 hours times 60 minutes. Hit enter. That's that many minutes. And then plus 30 more minutes, you get 1,170 minutes. So you do have to do some converting. It's kind of fun. 1,170 minutes. So what we're looking for up here is h of 1,170 minutes. You don't have to write minutes in there. Now, if you go to your graphing screen, can you just type in trace 1170? Yeah, if your window includes that number, which we went out a whole day, so it should work, you got it right there. So you're going to write down negative 18.092 or 093 feet. Now I'm going to ask you to interpret that. It's a negative number. At this time, was the tide coming in or going out? Going out. So you could say, you can interpret the negative, the tide was positive 18.092 feet above or below sea level? Below. So this is what we could do in interpreting a vector which has a magnitude and a direction in this case. It was 18.092 feet below sea level with the tide doing what? Going out. So that was the ebb tide. So those types of questions, pretty easy. If you get a negative number, I might ask you to interpret it. In this case, it would just be below sea level by that positive amount. So give you a t-value, you can graph it, plug it in, trace, whatever. The other type of problem is when I give you the y-value. So let's read part E. At what times during the day was the water level 25 feet above normal with the tide going out? At what times during the day was the water level 25 feet above normal with the tide going out? All right, so let's go ahead and set up, first of all, what we're looking for in part E. I want to know now where h of t is equal to what? Well, here it just said I want to know when was it 25 feet above normal. Is that going to be 25 or negative 25? Positive 25. If it said 25 feet below normal, you'd have to set it equal to negative 25. So you got to read carefully. We want to know where h of t is positive 25. So I'm going to come down here and I'm going to change that little pink graph, which is the x-axis. I'm going to change it to 25. You can go into y2 though. And I'll wait for the whole thing to graph. Now, I said very specifically, when is it 25 during the day with the tide doing what? Going out. If the tide's going out, should the graph be falling or rising? Falling. Okay, so you translate it that way. So where on here is a point of intersection where the graph is going down? There's the first one, right? And then we have another one over here that is a full cycle away. Yep. So you can either find both of them, or you can find one and then add the period to it. Let's go ahead and find that first one. Second trace, number 5. Enter, enter. And then I can scroll over here. Close enough. Enter. Now, 205.760. Here's what you need to do on your paper. Some people are having a hard time with this. Some people put equals 205.760. Is that right? Does 25 equal 205? No. That's a misuse of equality, and you're going to lose a point every time if you do that. H of t equals 25 when t equals 205.760. And what are the units on that? Minutes. So I report 3 decimals, and that 0 is important. It's part of the accuracy. But if I'm going to convert it, I don't want to use the rounded number. It says at what times a day. So you could say 205 minutes after midnight. But let's do better than that. Let's go to the home screen. And if you hit X, enter, there it is. I'm going to store that as alpha A. All right, now if I call it A on my calculator, just to remind myself, I'm going to call it A on my paper. Let's go ahead and figure out what time of day that is, like clock time. How do we do that? Multiply or divide by 60? I have to divide it by 60, see how many hours it is. It's 3 full hours. So it's kind of like we did when we had those big coterminal angles, right? We divided by 360. We divide by 60, so it's 3 full hours. So I'm going to say 3 hours on my paper. And then I subtract the 3, which would be like subtracting 4 rotations. And now I want to know what fraction of an hour that many minutes is, right? So now re-multiply by the same number we divided by. And you get 25 minutes. And let's see how many seconds that is. Subtract the 25, and now I have a fraction of a minute. If I multiply by 60 again, I'll see how many seconds that is. That should be 45.643 seconds. So at that point, we don't go anything lower than seconds. So that's after midnight. So that would be at 3:25. We could just say 45 a.m. That would be clock time. Now, you can do the same thing for the other one, or you can just do what? What's the period? Yeah, 7:48 minutes or 12 hours, 28 minutes, right? So let's just do this. Let's just find the other one by saying and at 12 hours and 28 minutes. If I add plus 12 hours and 28 minutes, of course, we're going to get what? Still 45 seconds. 8 plus 5? 13. So you get 53. And then 12 hours later puts it at what? 15 o'clock? How about 3 o'clock? But this time, p.m. And again, that's using the period nature of these types of functions. So 3:25 in the morning and 3:53 in the evening. You're going to see twice in one day, you're going to see where the tide is at 25 feet above sea level, heading out with the ebb tide. All right, now we have a couple more minutes before I talk about the test. There's one other type of problem that I can ask you. I could ask you for how many total minutes was it above a certain height? Let's do this. For how many minutes was the tide at least 10 feet above sea level? For how many minutes was the tide in one day at least 10 above sea level? So you're going to put h of t is greater than or equal to 10. That would be what you'd show on your paper. If I had said below sea level, you would set it equal, greater than or equal to negative 10. All right, so then we're going to come down here, we're going to graph 10. And we'll do it again. And I will ask you a problem like this on the test tomorrow. So there we go. There's the tide. You can imagine watching a moo. The tide rolls in and the tide rolls out. See the water squirting out of his spout. Baby beluga. You know what? Let's not do 10. No, I want to do something smaller than 10. I just made that number up on the spot. Let's do 3 feet. Okay? Instead of 10. I want to kind of illustrate a point here. We'll do 3 feet. Now we got to wait for this to graph again. At least it's fun to watch, right? Like election results coming in.